You know, it's kind of wild when you think about it. How does your computer start a totally private, secure conversation with, say, your bank's website, when the entire internet is basically listening in? It's a huge puzzle in online security. But the solution? Well, it's incredibly clever. Let's dig into how it all works.
Okay, picture this. You're at a massive, loud party. You absolutely need to get a secret message to your friend across the room, but everyone can hear everything. You can't just yell it out, right? Well, that crowded room, that's the internet. And every single secure connection you make has to solve this exact same problem. So, how do they pull it off?
See, to have a secure chat, you and your friend, or your computer and a website, you both need the exact same secret encryption key. But that's the big catch, isn't it? How on earth do you get that key over to the other side, through that crowded room, without somebody grabbing it first?
It turns out there are really two main ways to go about this. The first is what we call out-of-band, which basically means you don't use the network at all. The second is in-band, where you have to get clever and use the network itself to share the secret. Let's start with the offline way first.
All right, so the most obvious way to share a secret is to just avoid the crowded room completely. Don't even use the network. This is the physical, kind of old-school solution.
Yeah, this sounds like something straight out of a spy movie, right? You imagine some courier, handcuffed to a briefcase, physically carrying that secret from one place to another. This way, you guarantee no one on the network can snoop on the key, because the key was never even on the network to begin with.
And hey, it isn't just about spies and suitcases. Other out-of-band methods could be using a trusted delivery service, just picking up the phone and calling the person, or even meeting up face-to-face to exchange the key. All of these are totally legitimate, super secure methods. But here's the catch. While this is about as secure as it gets, it's got one giant flaw. It is so slow. On the internet, we just don't have time to wait for a courier. When you click on a secure link, you expect that connection to happen, like right now. So this pretty much forces us to find a digital answer.
So if we have to solve this on the network itself, if we have to send something through that crowded room, how can we possibly protect it? Well, this leads us to our first online or in-band solution, using a different type of encryption to basically ship our secret key.
Now, this secret we're trying to share, it's called a session key. You can think of it like a temporary password that's only good for this one conversation. It's ephemeral, which is just a fancy way of saying, once your chat is over, that key is thrown away. For your next session, you'll make a whole new one.
So how do we send this session key safely? We use this really clever digital lockbox system. Here's how it goes. First, the website server sends your computer its public key. Think of this as an open padlock that it just hands out to everyone. Second, your computer takes that session key, sticks it in a digital box, and snaps that public padlock shut. Third, this locked box gets sent right across the network. Anybody can see it, but nobody can open it. And finally, the server uses its own unique private key, the only key in the world that can open that specific padlock, to get the session key out. And just like that, the secret is sent safely right out in the open. Pretty neat, huh?
Okay, that lockbox method is genius for sure. But there's an even more elegant, almost magical solution that we use constantly. It's one that completely avoids the problem of sending a secret in the first place.
No, seriously, just pause and think about that for a second. What if two people could somehow come up with the exact same secret key at the exact same moment without ever actually sending it to each other? It sounds totally impossible, but this is the heart of modern key exchange.
This whole process is called a key exchange algorithm. And it's not really encryption, it's not hashing, its one and only job is to let two different parties independently build an identical secret just by using a mix of public and private info.
Okay, let's use the classic crypto characters, Alice and Bob, to explain this. Here's the setup. Alice takes her own private key, something only she knows, and she mixes it with Bob's public key, which everybody knows. At the exact same time, Bob takes his private key and mixes it with Alice's public key.
Now, we're not going to dive into the super complex math here, but the absolute crucial part is that the public and private keys for each person are mathematically connected. They're designed to have this special relationship. And because of that special mathematical link, the final result of Alice's calculation and Bob's calculation is identical. Bam! They have both, at the same time, created the exact same secret key. The key was never sent across the network. It was just born simultaneously on both of their computers.
It's an absolutely incredible piece of cryptography.
So why does any of this complex handshake stuff matter to you? Well, because this magic is the quiet, invisible process that really is the foundation of the trust you put in the internet every single day.
So let's just do a quick recap here. Agreeing on a secret key is that all-important first step for any secure online conversation. The physical, out-of-band stuff is safe, but way too slow for the web. So we have to rely on these in-band methods, like sending the key in a digital lockbox, or even better, using one of these key exchange algorithms to create a shared secret without ever having to send it at all.
Seriously, every time you see that little padlock in your browser, every time you buy something, send a private message, or check your bank account, one of these unbelievably clever key exchange processes has just happened in the blink of an eye, protecting your stuff from that crowded, noisy room we call the internet.
It's just a powerful reminder that some of the most difficult problems in our digital lives are being solved by elegant, creative, and, yeah, sometimes downright magical mathematics, all working silently in the background. It really makes you wonder, doesn't it? What other impossible things are being solved for us every day, all thanks to a little bit of clever math?